Alright guys, welcome back to Modarra Mondays. First of all, thank you guys for everyone that's been commenting, following the Instagram, commenting here on YouTube or on Instagram. I really appreciate all the comments. We've been getting a bunch of comments. I've been replying to every single one of them. So thank you so much. Keep it up. I appreciate not only the support, the ideas that you guys are giving in the comments. I love that. And just any feedback on the videos and whatnot. I'm trying to accommodate as much stuff as I can, but also stay true to myself, so that's kind of where I'm at. But again, if you guys are new here, we are making machined bracelets. This is a brand that I want to build to experiment with different wearables as far as bracelets, chains, maybe get into other things, but for now we are starting with this bracelet. It's stainless steel. We plan to do more exotic materials. I know a lot of people have been commenting about that. Yes, that is something I want to do, but the first step is to nail down the design, nail down the programs to make these stainless steel ones, and then we will venture out. So in last week's video, we showed machining some links on our awesome fixture here. What we're going to be working on is, today's Sunday, you guys are seeing this Monday, is I'm going to be adding some new tools to the machine to even further make these links better. We're going to work on some different tool paths, but then we're also going to be working on the OP-2s, because if I've shown these in the last week's video, the way these are machined, we have this nasty tab that stays there. So we have to figure out an OP-2. So I have a program that I want to try on the machine before I make a fixture. We can hold one in a vise and just test the program out, make sure that it actually works and does what we hope it should do, and then we're going to potentially make a fixture. But I want to add some more deburring ops to these parts, get some tools in the machines, and go from there. I'm kind of strapped for time here, but we're gonna get as much stuff done as possible. Alright guys, let's get to it. Okay guys, we got our links back from Electroplating. This was a sample run they did. This took about 2 weeks. I can't complain because it didn't cost me anything, but I want to go ahead and take a look at these, and we're going to compare them to this link here. Is our latest off the machine one, which actually looks really good other than that surface finish on those two flats, but we'll talk about that. So just right off the rip, you can see it's gonna be tough. So I guess I should back up. These links were, all the ones that I sent were kind of just some hodgepodge bad links that I found on my little scrap tray here, or my prototyping tray. Some of these I had polished before with a buffing wheel. Some of them I had tumbled and it didn't really do anything. Some of them I flat sanded with sandpaper. So finish to finish, they vary. So in this case, these ones are like straight off the machine. This is when we were milling them in a different orientation, so you can see the milling lines are in a different order. But if I find one that, yeah, so like here's a good example. The one on the left here, you can see is a really good surface finish compared to the one on the right, and that's because this one I clearly hit with a buffing wheel beforehand. Now, obviously these look great. They do have kind of a, I don't know. I would assume this is how like mass-produced like cheap chains and stuff are made as far as finishing goes, because it's got this like slick texture, and the sound of them, I don't know, like it feels weird to me. Now that's just the machinist inside of me. I don't know what that is inside of me that's saying that they feel kind of odd to me. So I don't know. I have mixed feelings. It definitely does not remove machining marks. Like, that is for sure not what this process does. But it does, I'm trying to see off camera, it didn't remove any of the burrs that I thought it would. I thought, for example, some of the burrs on like this edge here, I thought it would knock those down more. It really didn't. So is this a viable option? Yes, but I think we need to send them better parts, but I think it's really a determining factor if I like this finish. It very much looks like chrome finished versus kind of a muted muted, just off the machine finish. I don't know if it's really hard to share the comparisons, especially when you're butterfingers over here. So I don't know if you can tell the difference. Again, it feels like chrome. That's kind of the best way to describe it. So I think this was one of our latest links here. I think we can get this link to the point where we actually don't need to do any outside processes. That's kind of my goal. Part of the reason is, one, I think we can get away with it. I think we can push ourselves here. And then also, it would be sweet to not have to send parts out just from logistics. And also, we can continue and really say this is truly all done here in Seattle, because this company was out of state. I think it was like Chicago or something. So this is the link that we have. I want to talk about some of the things that I don't like about this link, which are, we still have this big ugly chunk of material. So we're going to be working on a OP-2 fixture, and we'll talk more about that. So that'll remove that. I want to add, let's get a pointer here. I want to add, actually, let's just use our big link. I want to add a chamfering toolpath on this here. Currently, there isn't one. We just chamfer the inside of the hole. I want to add a chamfering toolpath on this edge. The problem is we can only do it on this top edge here, because this edge, we're using that material to hold on to. So in the second op fixture, we're going to deck this face, not touching this wall because we already finished that. Deck this off, get rid of this tab, and then we're going to chamfer that as well. So it'll be a 2-tool operation. I have a fixture in mind that I want to try. So I want to add chamfers to both of those. Then I want to attempt to add a chamfer on this edge here. We were able to do this in earlier links because, let's see if I have an example. We were able to do that. Yeah, here's a good example. You can see the chamfer hitting the light there. We were able to do that because we were making these one at a time, and I could 5-axis tilt this like this and come in here with a flat tool and just cut that. Now that we're racking them up salami style, I can't tip the fixture and do that on all orientations. I can't reach all of the parts. So I'm gonna have to either create a sketch at an angle and try to make a tool path that follows that angle to kind of replicate that, but I really want to chamfer that edge. We'll chamfer these back 2 edges. So again, this edge here, flip it, this edge. I'd like to get these 2 long edges in here and here. Then the only other thing that we have not chamfered that has been bugging me, first of all, this is gonna make some people scream in the comments. For the last video, I did not chamfer before I tapped these holes, so we need to add that in there because it is raising an edge. Go figure. But I want to take this lollipop tool and I want to come in here and I want to hit this and this. And that will deburr the inside of that hole and the inside of that hole. This is going to be, I don't think it'll be that hard, but this is definitely getting to the point where like, I haven't like deburred apart this thoroughly, but you can see this would be perfect. I could come in, just touch and touch and clean up. You can even see that raised edge there and just clean those 2 faces up. If we can do all of that, this part will be fully chamfered as far as the machine can do itself. Another thought with these chamfers here is we could just leave it up in this orientation and come in here and chamfer it like so with our same chamfering tool. I want to get those corners as tight as I can because we have a chamfer meeting a chamfer, so I want to play with that. But that's what we're going to be up against. Same thing down here. We're only going to be able to get so close to the wall, and it might look weird. So I want to play with that. But for sure, we're going to try. We are going to try to deburr this part as best as we can. This thing really likes to focus all over the place. I'm really excited about this, and I have 2 of these tools on hand. We're just going to go in, make a sketch, and go bzz, bzz, and I think that will work. So that's what we're going to try. And then another thing, I'll go downstairs in the shop and show you guys, but I got a 5-flute end mill that I want to make our finishing tool to make this finish even better. It's already really good. I'm already really happy with it, but we'll make a dedicated finishing tool for the sidewalls here, which will be 5 flutes instead of 4, which will be awesome. And then we have to figure out maybe using the same finishing tool for these faces, because we'll use the ends of the tool and then we'll use the sides of the tool. So maybe that'll actually work out. So we got to set up some dedicated roughing and finishing 3/16 end mills, along with, we're going to put this lollipop tool in the machine. And then I think that's all we're going to need as far as new tools go. Oh yeah, and then I did order I can't remember the size, a larger tool to machine this out of the link. You guys like my little, like, 2x and 4x, I think it is, like, prop size. It's really helpful for, like, talking about it and showing you guys stuff. So I ordered a larger tool to make this slotting operation more or less faster. I bought cobalt tools instead of carbide. I swear on MSC it was carbide only. So somehow your boy bought cobalt tools, so we won't be able to add that time-saving thing yet. I'm going to order those and get those in as well. But I think we are on the right track to not only making a better part, but speeding up the operations. Another thought I had was, since we could tip all of these links down, right? We've got all of these links lined up like this. We could slitting saw all of them. That is something I've considered, but I think for now I like having it per part and just adaptive this out. We're actually, instead of adapting, we're going to move to slotting, and we're going to do it really quickly. So that's what we're going to be doing. I think we can get some good finished parts. I just want to get a good OP-2. Right now we have a really solid foundation for a OP-1 part here, but I want to get a better OP-2, or as of right now we don't even have one. So I want to figure that out to kind of finish the part, because I feel like we're only half the way there right now. We got to get that tab off and make sure it's nice and clean. So we're going to continue to optimize, deburr, make this thing perfect, and I think we might be able to get away with not having to send these out to get, or even me polishing them internally. But I love that M on the middle. So let's go ahead and get to it. Okay, couple housekeeping things. I got some Torx head cap screws, or button head screws actually, to replace these set screws. They're a little bit shorter, but the main thing, like I talked about in the last week's video, is I wanted a Torx drive. This way I can better torque them down with my little torque wrench. And then, like I said, these things were just stripping like crazy, and I've measured the Allen key and everything. I don't know what's going on. It's not metric, it's not inch, it's some weird in between size. So these are going to work a lot better, and they look a lot better in my opinion. So we got those. We also got some of the new end mills, and then what we're going to do is we're going to put in the lollipop end mill, along with, we're going to separate the two 3/16 end mills. So we have a 5 flute that'll be just for finishing, and then we have another one that will be for roughing. So we got both of those. So we have to put in 3/16 finisher, lollipop tool, and I think that's it for as far as new tools that have to go in the machine. So I got to find spots for those, and then yeah, I think that's it for now. Alright, call me crazy, but I'm going to probe this part. It's literally just in the vise. We have 2 tool paths. One is going to come clean up and hopefully remove that tab, and then the second one is going to chamfer. So let's go ahead and try it. Okay, I just ran the tool path. We're under the microscope now. This is difficult. I'm not gonna lie, I'm definitely struggling to get the results that I want here. And so I'm gonna try to illustrate the problem here. So I guess we'll point up here. It's really hard to see, and so this is the edge that we chamfered. I don't know if you can see that. There is definitely a chamfer there. Now, can I zoom in on this? I can. Okay, maybe this will help a little bit better. So, You can see the chamfer there. I think it's probably better if I hold the part. So you can see the chamfer. It's definitely kind of wonky on that edge there. But you can also see this line. Now, it's clearly, if I take this out and I look at it, is this deeper or is it a high spot? So it's deeper than the original. Where are we here? So, a couple things. One, obviously I don't like that line. That there. I don't like that. And then, man, the problem that I'm running into is being able to get a reliable OP-2. Now, part of the other problem is what you can't see here. Maybe you can see it actually. You can see this is where, can you see that? Oh, it's tough. Let's see if I can hold it up a little bit more. There, right there. Long story short, the chamfer needs to be larger to get rid of. This is basically a burr formed by where I am holding on to the part in OP1. This is the tab. And this chamfer is more or less, we're trying to eliminate that tab. And it's hard to see, but this bottom edge of the chamfer is protruding. It's actually sticking out, causing a burr. You can really see it here if I hold it at that angle. Now let's see if I can show. Here's a part that has not been chamfered. This is the tab you can see here. And so you can see this is basically our tab thickness here. I can't remember what it is, 10 thou, whatever it is, 5 thou, whatever it is, and you can see that is what we're trying to also eliminate. So we're cutting this ugly chunk off, obviously, and then we're trying to machine down and then chamfer this. So this edge goes, it's I guess that'd be perpendicular, right? Right now, there's a burr forming. So I can try a few things. I can try increasing this chamfer size. But what I just don't like, I don't like a couple things. I don't like how we can't get that chamfer closer to that edge. I mean, I understand I'm looking at it under magnification at this point, which you got to be careful because you can drive yourself crazy looking at it under magnification. I definitely don't like that line. And that's a simple Z depth issue. And so I guess you could probe your Z. It's tough because there's not a lot of surface area here. It's not like I could probe. I guess you could if you really. That'd be tough. I'm just thinking long-term reliability wise. So this is kind of what I'm up against. I'm trying to think if there's a better way to tab this part off. I'm trying to, because this doesn't seem reliable from an OP-2 perspective. I feel like there's too much going on here, and so this makes me wonder if we should go back to having a tab somehow out here and then having just a simple flat face that we could machine and get rid of the tab. Basically, is there a way to simplify the OP-2 so there's not as much going on? Because if we did a flat face on the end of the link, there could be just a simple OP-2 where we literally just machine it flat and there would be no chamfering or no nothing like that. This is tricky. This is the hard part about this part. I mean, the OP-1 is pretty straightforward at this point. You can also see this is that long edge that I really want to also chamfer. I guess while we're here, let's look at our engraving. Actually looks pretty good. I'm actually pretty happy with that. So, and then you can also see on the inside, yeah, this really magnifies it. That burr on that hole is on both sides. I want to, that's pretty nasty too. So I want to use that lollipop tool to eliminate these burrs. That I'm pretty confident we can do. But this is where it gets tricky. This is where I really start to push myself. You can also see there's a pretty nasty burr there. We talked about that earlier. I already added that chamfer toolpath. So, and of course here's this side is not chamfered, only the hole is chamfered. So I do want to add a chamfer op. Yeah, this is, sorry, I'm just kind of rambling and thinking out loud here though. This is the tough part of making this part. It's also interesting, if I'm talking out loud, there's also kind of a, I don't know what this is. There's like a secondary line or something there. I don't know if that's from the, I'd have to check if that's the mismatch, because that might be a mismatch because we use our 3/16 tool to rough this edge, and then we come back with an 1/8" tool. I'm wondering, that almost looks like the contour is not set to the right geometry or something. It almost looks like it's offset. So yeah, I don't really know. I mean, I'm gonna throw those two tools in there. I'm gonna put the new finishing tool in there so it's in. I'll put the lollipop tool in, but I'm really struggling to figure out a reliable way to tab this thing off and to still get good chamfered edges on this thing. So yeah, I'm gonna go do that while I think about this, and then we could also test the lollipop tool code if we really wanted to. I still gotta work on programming that. That's been difficult as well. So yeah, sorry for the rambling, but this is like the reality of it is this is a very small part that I'm trying to chamfer and have a reliable process with, and more or less, I mean, it'd be awesome to one and done this part, but I don't think that's possible with the standards I'm trying to keep. So yeah, okay, let's keep thinking. All right, we're back under the microscope. I just did one more link because we have the parts. I increased the chamfer size, and I think we got rid of the burr. So you can see now this is actually looking really good. It also looks really good in person, and that's really what I care more about. But you can see this chamfer is much larger, and I think we got rid of, please tell me we did. Oh, it's hard to tell. Because I still see a tiny little point there. I mean, it's way better than it was. That's for sure. Way better. I think I could get the chamfer a little bit closer to the edge. I mean, we're pushing it. I have like 3 thou clearance. You know, I'm trying to get rid of this little chunk here. Might not be totally possible, but again, under the microscope, you see everything in person. This thing actually looks way better than the last one. We still have that step. That's a Z height problem. That is solvable. Do we have 2? We still have 2 of them. You can see that first little one. So yeah, there's something there that I've got to uncover, but I think we might be able to get away with making this chamfer a little bit heavier, which is fine because originally it was 5 thou, but the actual edge chamfers here, those there, I believe are 10 or 20 thou, so it actually matches those better being a little bit heavier, so I could get behind that. We still have the hole chamfer, that's still there. It's a little bit off center actually. Maybe? All right, we need to focus. So I think we might be able to make this work. There's a few things that I think I could change in OP1 to make this even better. So I think at this point, we are going to pause on dialing in the OP2 here because I think there's more problems on the OP1 that need to be solved before we get any further. So I think one of them being is, what is this secondary? Because this first one is from what we just did, but this tinier one here, figure out what that is, add the chamfers to get rid of these crazy burrs on these holes. Those are pretty gnarly looking at them under magnification. We'll add the chamfer on the top of the threaded hole to get rid of that. And then we got to figure out how we can chamfer some of the inside of that. That's going to be tricky. I know, I mean, let's just start. I mean, we know how to do the tapped hole. I already programmed that. And then the lollipop tool, we got to figure out a good tool path. So I think really, honestly, at this point, it's going back to op1. I didn't think we'd be doing much of that, but we're going to be doing that. So I think it's time to sit down and program. I think I'm going to go throw those tools in before I forget. And yeah, but this is looking a lot better than it was. I mean, you guys saw the last one, so this is looking a lot better. So let's go ahead and get to that. All right, so what we're gonna do is I reprogrammed, or I added to our current program, some different deburring and chamfering tool paths that I wanna try on a link. I'm not gonna do the full set because I don't think there's any point, so I'm gonna just test on one of these links. So what we're gonna do is we're gonna actually cut this one out of brass. There's no real reason for doing this other than I kind of want to. And yeah, I mean, there's actually let's do this. Let's go back to doing it horizontally. Everyone seemed to really like that idea. And there was actually a lot of great comments on different ways we could drill holes and use air to push these bar stock out, and just all sorts of cool, clever ideas that you guys had. So I really appreciate that. But we're going to I'm going to take out these first few and only load the first one. I just want to give myself a little bit more clearance just because I don't want to risk anything here. Again, these set screws are so poorly. I don't know what the deal is with these. Alright, look at that. I love that. Take the whole stick out. That's awesome. So, added some chamfering tool paths, added the lollipop tool path. That's definitely something we're going to have to dial in. I'm not going to cut this part off. See, like this one's completely skipped, so I can't even take that one out. So, we're going to basically be testing a bunch of tool paths here. I'm actually going to take these few set screws completely out. I understand you guys probably can't fully see what I'm doing here, but you get the gist for now. And then, yeah, we're going to use our new Torx. Oh, that's so nice. I love that. So, I'm just actually curious. Okay, yeah, we've got clearance. So I'm just going to put one in there just for, we can check clearances. But do they fit next to each other? That actually might be a problem. Oh, they don't. Can you guys see that? Back to back, we have barely, I didn't even think about checking that. I didn't think the heads were going to be this large on these. It's maybe like 30 thou, so we might have to just turn these down in the lathe, which is fine, but we'll go ahead. I guess we'll use one Torx and one set screw on this one. Not really too worried about that. Definitely want to add a channel back here for chips and coolant, so when we blow into these, we can actually get the chips and coolant to go through. So I've got this piece of brass. I'm going to have to cut this in half. So I'm going to go do that. We're going to mount this up and we're going to go for it. So let's do it. So one thing about what I'm doing right now is looking for calipers. I like to try to test as many things as I can in one shot. So not only are we testing new tool paths here, we're also going to be machining one out of brass because you guys really want to see different materials. I really want to see different materials. And this will just start to give us a glimpse into the future. Obviously, speeds and feeds for brass are pretty, I mean, you can run it pretty much at whatever you want. So I'm not going to adjust speeds and feeds just for the sake of it, because we just don't need to change them. So we got our little fixture here that I almost forgot we had. Just like that. So I didn't even need calipers. Look at that. So yeah, we're going to not only be able to test tool paths here, but we're also going to be able to test a new type of material, see how it is. Obviously brass is very soft compared to stainless. So nice thing is too, is I worked at a few Swiss shops. Those were I only worked 2 jobs ever in my life for someone else. It's all, other than that, it's been all for myself. And it was 2, one was a Swiss machining shop, and I mean, you can learn this also just by watching YouTube videos. But the nice thing about brass, it's soft. You can run it at your program speeds and feeds for whatever you're already cutting. So if you're cutting titanium, you could run it at those speeds and it'll be fine. It's not going to damage your tools. And you can also run it with no coolant. And so in this case, I really want to watch that lollipop tool. Obviously, it's pretty easy to toggle coolant on and off on scenarios like this, but it's nice to know that I really don't have to worry about it here, whereas steel starts to become somewhat of an issue pretty quickly compared to brass. So I'm going to torque those down and we'll get off to the races here. So I've got my little Sandvik torque wrench. We're currently set to around 10 foot-pounds. I think that's what that is. Oh no, that's 10 Newton meters, never mind. But it just really doesn't matter right now. That's plenty tight, and those are plenty tight. Again, I'm really confident in this fixture. I'm not too worried about it. Okay, we probed. Let's go ahead and get this running. That just broke a tool. Honesty is the best policy. Why did that happen? See, it's so easy for me not to show this, but this is good. I feel like my stock was sticking out longer than it should have been. I guess you guys can't see this. Yeah, that was going to take way too big of a cut. Let's see here. Why would that have been the case? I gotta go check Fusion. I'm willing to bet that was sticking out too far. That doesn't really make sense though, because we used our fixture. I guess I gotta go confirm that it is in fact 1 3/8. I am curious though. Well, no, I was just thinking maybe our screws got in the way of our fixture, but they were up on top, so that's not true. Alright, let me go check Fusion and I will report back. right, we machined a brass piece, and I'm not gonna lie, this is kicking my ass right now. This brass piece looks like garbage for a handful of reasons. So let's start with the pros. You can see we definitely deburred the inside of that hole, and this one we need a little bit more, but it proves that we can do it with the lollipop tool. I think my tool path's a little bit off. It looks a little bit heavy on that one side, so that's something we're gonna have to figure out. I definitely did not, you can see the burr on the top of that, I did not chamfer that enough. Again, we know we can do that, so those are easy fixes. The lollipop tool, I'm still questioning if that's just truly the best option there, but we are proving that we can deburr that feature, which is good. The chamfered edge on this side, I mean, it looks fine. What's weird about this part is dimensionally, this thing is off by like almost 10 thou in most directions, like 5 thou here, 5 thou there. I did break that one tool and I swapped it, and that was what would have cut most of those features. So I don't know if that tool was really worn out or something weird like that. It doesn't really make any sense to me. I'm not using cutter comp on any of this as of right now or anything like that. So yeah, this part is oddly small in a bunch of different dimensions. That's why there's not much of a chamfer on these top edges. It's barely there. And then if we flip it, like it's barely there compared to our stainless part. So I don't know what the heck went wrong there. So I'm gonna keep it a buck. This part is really challenging me. I mean, I love the challenge, but I mean, come on, give me something here. So I'm frustrated that I can't get some of these features to be deburred. I mean, there's still this long edge on this part that we need to figure out. And this tabbing method, I just feel like it's, yes, we could make parts like this. 100% like we could do it. Is it the best way to make them is the question that I'm trying to figure out. And the problem is with the links, again, this is such a majority of this bracelet is links. And so we have to nail down a process here. You could argue that we don't need to nail this down right now. We could start making them, you know, in a less efficient manner and then go from there, you know, start selling parts, stuff like that. But I really want to get this to be reliable, and right now it's not. It's all over the place. So it's making me rethink if we should change completely our machining strategy of making these. Because the problem is we have a few things that we're up against. We have all these different edges that we want to deburr. The problem is some of these are not possible to be deburred properly, in my opinion, depending on the setup. So I don't know if I can illustrate this with my larger link. So currently we're making it in this position here, you know, upright. We can tilt it and get access to certain sides, but since we're lining up pieces of stock, that doesn't mean we have access to all 5 sides of the part. We're kind of using my 5-axis as a 4-axis in this sense of making them. And we don't want to make them one at a time. That's actually how I made this bracelet, was every link was made one at a time. The reason we don't want to do that is because tool changes would just kill the cycle time here. And I have zero interest in palette changing or even opening the doors to swap out one piece and do that 25 times to make one bracelet. Again, could we do that to start selling bracelets? Sure, but I'm really trying to avoid that because I'm trying to look long term here, and that's just not it. So that's kind of one of the constraints. The next one is we were able to deburr these long edges inside of this like fork here on the 5-axis one at a time because we could simply tilt it at 45 and cut those features and cut a little chamfer on that. And that's what I did with most of these. So I can't get that feature in the current position here. What was really nice about doing it one at a time is I could get tight in that corner, and I could do that. I'm trying to think. I could also get tight in this corner, these corners here, because I could rotate, tilt, and come in there. So I could do that. The other thing is the tabbing. I don't like the tabbing method. So I'm just playing devil's advocate here. If we go back to making it one part at a time, so we have full range of motion and controllability of the part here, we could definitely chamfer things tighter. We could definitely chamfer that one feature better, more properly. How do we tab this thing off? That's the other thing. So, okay, put a pin in that. So we could potentially do that, figure out a better way to tab. The other thought was, instead of orientate the part like this, if this is the stock here, the round bar like this, what if we orientate the part like this? And so now we machine everything. We have full peripheral of all these radiuses, which is what I was trying to do with the current tab, so that would be good. We could drill and tap, do all that. We could come in here with a key seat cutter and cut that. We could lollipop all that, boom, boom, boom. And you actually could key seat cut this bottom feature, and then all you would have to do is flip this thing, deck it to get whatever tab. You would put the tab on this larger face, and then chamfer that, and you would be done. The problem with that is with the key seat, well, actually, one thing, we could get those long edges with the key seat cutter and chamfer those properly. And two problems with that is we couldn't get these chamfers as tight as we'd like them. We'd basically be having what we have, what I showed. It's going to be close, which in person, I don't know. I mean, it's good, but it's not patent good in my opinion, and that's what bothers me. Like, this is totally a passable part, but I don't like how the chamfers are so close to meeting, but they don't meet. So, okay, back to this. So we couldn't get those chamfers. We could get these long edge chamfers with a key seat cutter, but the problem is, and, okay, before I say the problem, we could line these up in our current fixture. We'd have to use larger bar stock, I think. It's actually a good question. Actually, maybe not. I'd have to measure this. I don't know what the overall width of this is. If it's less than 3/8, then we don't. But with the key seat cutter, I've already measured that key seat cutter needs to be pretty large in diameter, and we couldn't use our current fixture because they're too close together. So we would have to make another fixture and space these parts further out because that large diameter key seat cutter would have to have room to sweep around. So, I'm open to suggestions if it's not obvious. But yeah, this is a tough part. This tiny part. Again, we can make functional bracelets, like, that's not, it's making a good quality part. Or a higher quality part. Yeah, it's that tabbing. How do we get... And, well, actually, another problem. In this orientation, if we do the, whatever you call this, the hot dog method, right? And if this is the vertical, this is the horizontal method, we couldn't engrave the M on there. We'd have to do, that'd be a whole third setup. Alright, I'm not gonna lie, this week was a little bit hectic. We made some progress, but then I feel like we took a few steps back, but that's okay because next week I want to take a break from links and I want to go into screws, because once we get screws dialed in, that shouldn't really change. We know what the link is going to be, and unless I completely decide to change the link design to make it more manufacturable, but I feel like in that last clip, I hope you guys followed along with all of the issues with the different orientations, the different chamfers we're trying to cut, and the different features, how it really is a very interesting problem that we're up against here. So I'm going to think about, would I even consider changing the actual link design of the bracelet? What would that actually do for us? What would it look like? What would it actually serve? Would it actually help us make it more manufacturable? I don't know. So I'm looking for advice on a couple things or ideas. One, how would you tackle this part? How would you deburr it in the current setup? Would you change the orientation? What would you do there? And then also, oh, what was the other thing I was going to mention? Yes, OP-2. So kind of how would you OP1 and OP2 the part? Or could you one and done this somehow that I'm just completely missing? So I'm very curious to see what you guys have to say. Again, thank you so much for the support. We're almost up to, I think, 400 followers on Instagram. We're getting a lot of subscribers. I really appreciate it, guys. Seriously, drop a comment down below. I love reading them. I'm replying to every single one of them. And again, we are trying to build a bracelet and wearables company that supports, let's see if we can get this. Come on. Let's see, might need a thumbnail here. So we're trying to build a business and a brand that supports makers. It's for the people that realize how things are made and appreciate the little things, like these little chamfers, these little edge breaks, you know, machining, manufacturing, all here in Seattle. That's what this is for. We're starting with bracelets. I have a bunch of other ideas, but this is turning into a pretty tough challenge. So I think next week, like I said, we're gonna switch it up. Depending on if I might get a bunch of good ideas from you guys, and I might want to really dial in the links next week, but I'm thinking I'm gonna want to take a break and maybe go to screws or start talking about the class, because there's a lot to talk about there. So that's where we're at. Thank you guys so much, and I'll see you guys next week.